Hi, Algo fam. Welcome to the session 2 of our TypeScript bootcamp. Thanks for joining us and starting this journey. A quick recap of yesterday's session. We create our project using AlgoKit. We wrote our first smart contract and add the basic functionalities for the marketplace using TypeScript. And on the chat, you can share your thoughts on yesterday's session. And let us know if you were able to create your first marketplace smart contract using TypeScript. And today we are going to create the test to ensure that everything is working as we expect. And as we discussed yesterday, creating the test is something that you must start doing and is a good practice. But Joe, there is another reason to create the test.
Yeah, so I mean, like you mentioned, testing, is a good way to make sure that everything works as you expect. But also in today's session, because it's our first time learning how to interact with a contract, what we learned today is not just going to be useful for testing our contracts and making sure they work correctly, but also it'll be useful for our front end integration as well, because we're going to use a lot of the same concepts that we learned today in our testing in our following sessions on our front end integration. So today we're going to learn how to use the new Algorand client, which is, even if you've been building on Algorand before, you'll get to see how AlgoKit has improved. And then we're going to use that same feature for front end integration. So today's a really important lesson in not just testing, but how we interact with our contract in general.
Yeah, that is a pretty important part because using the client, we will interact with the smart contract, and that is the important piece that allows us to communicate between the front end and the smart contract. And for example, talking about the testing, once you start doing that, you get used to do it. So yeah, it's a pretty good practice, and in that way, we ensure that everything is working as we expect. So we are almost ready to start today's session. And who is ready for the session 2? Come on, Algo fan, let's feel the energy. And I'm very excited and looking forward to tomorrow's session because we are going to create the user interface. That is a pretty important part in every project. A quick reminder, the sessions are recorded, and once the session is over, you will receive the recording in your email. And in the session 4, I will share with you the link so you can claim the certificate of completion. This is not just an NFT, it's going to be also a verifiable credential. And in tomorrow's session, I will show you the preview of the certificate. So, George, over to you. We are ready to keep learning. And I really love today's session because we are going to learn a lot of things. And in some way, we can replicate the same structure for the testing to interact with the SDK. So I really like that.
Exactly. Yeah. So I'll get to the content in just a second, but I did see a question here that I wanted to address. In the video, when I did an AlgoKit init, it just asked me one question: what is the name of my project? However, there has since been an update to AlgoKit where it'll ask for the name of your project and your contract separately. So previously, the version that was in the video, I named my project Digital Marketplace, and that automatically named my contract Digital Marketplace. But now it will ask you two separate questions. So I think by default, the contract is called Hello World. You can name it Digital Marketplace or really anything you want. Everything that we go through is going to be the exact same, except the name of the contract, of course. So the init wizard did change a little bit, but everything after that point is the exact same. So feel free to name your contract whatever you'd like. If you want it to match with the bootcamp exactly, you call it Digital Marketplace. But the name doesn't matter, as the functionality is going to be the exact same whatever we name it. So don't worry about that. And I see someone in the chat asking for the GitHub repo. Let me share that. So if you were not able or missed maybe some of yesterday, you can get caught up for today. So let me get that.
And also, I just saw a question regarding the certificate for the Python bootcamp. This morning, you should receive an email with all the instructions. So please take a look of your email, because over there we send again the link so you can claim the certificate. If you have any problem, please send me an email and I can help you with that process.
All right, great. I think that is all the questions, so we can get right into the content. So again, I'll play the pre-recording. If there are any questions, make sure to use the questions tab, and we'll pause if there are any questions that should be addressed before we continue. All right, now that we have written our contract, we can go ahead and start to test it, and more generally, start to think about how we actually interact with our contract. So we've written our contract here, and to get here, we started with the template that AlgoKit init provided. In here, it generated under contracts this digital marketplace file, because that was the name of our project. And originally, it had a calculator contract with a do math public method. And if we take a look at our test here, we can see here that this was also all generated by AlgoKit. But if we scroll down, we'll see that our IDE knows that our create application now takes arguments, and it knows that our do math function doesn't exist on our marketplace anymore. So the question is, how does our IDE know? And the answer is that we are using this auto-generated client from AlgoKit. If we do an npm run build, and we take close attention to the output, first we generate the TypeScript code to teal, and then we do this other step where we generate a TypeScript client. And this client is automatically generated and then written out to this contracts clients digital marketplace client.ts file. And if we take a look at it, this is all auto-generated. And all the lines of code here are for writing a type-safe client that we can use in our tests in our front end. And because it's typed, we know that when we change our smart contract, we're going to have to make changes in our front end. This makes it much harder to update your contract and have your front end out of sync, because those two are linked together through this generated client. So what I'm going to do is I'm going to go ahead and start updating my test to reflect the contract that we actually have now. So the first thing I'm going to do is, well, actually first, let me get rid of these two test methods for now. And let's start up in our before all. Actually, before we get there, let me explain a little bit about what's going on up here. So this test is going to be written using Jest. So we have our typical imports that we do when we write a Jest test. If you're not familiar with Jest, it's the most popular testing framework for JavaScript. There are a couple of other frameworks, but they all follow very similar patterns. So even if you want to use another one, a lot of what we do here applies to other frameworks as well. Now, we get into the Algorand specific stuff, where the first thing we import is our Algorand fixture from AlgoKit utils/testing. And this is going to help us set up our tests and make sure that we don't have to do a bunch of manual things in order to test our contracts. And instead of writing boilerplate code to set up our environment, Algorand fixture does it for us. And then we're going to import our AlgoKit from AlgoKit utils as we normally do. And then we're going to import our digital marketplace client. And once we have all our imports, we set up our fixture. We instantiate it by calling Algorand fixture. And we're going to go ahead and configure populate app call resources to true. Now, if you're watching this shortly after this video comes out, so sometime in April or May, then you probably still need this option and you'll probably still see this in your template. However, in the near future, this will be enabled by default and you won't need to enable this explicitly. So if you don't see this in your test contract that AlgoKit generated for you, don't worry, that probably just means that this was enabled by default and we don't have to explicitly do it. And coming down here, we're going to have a test suite wide variable called app client. And this is going to be a variable, and this is going to be an instance of that digital marketplace client that allows us to interact with it. Now coming down into a before each, our fixture. So again, this was provided by AlgoKit. This has a method called before each, and this is code, as we can see from the name. This is a method to run before each test. So how Jest and many other frameworks on JavaScript work is we have this special before each method, and that means that this method is called each test we have. So actually, if I bring back my other methods, for example, what happens, it's going to see that there's this sum test, and before sum runs, it'll call before each. It'll go on to the next test called difference, and before difference runs, it'll call before each. What this function exactly is doing isn't super relevant, but basically it's just setting up our environment for us. So we're going to do that before each test. And now what we want to do next is in our before all call, this is a function that's executed once before all of our tests. So here we have two tests, meaning we have two before each calls, but we only have one call to before all. So in our before all is executed before each. So we need to call before each explicitly. And then we need to get our Algorand client from our fixture. And we need to get our test account from our fixture context. So what are these two things doing? So our fixture, like I said, sets up our environment. Our Algorand client is how we're going to interact with that environment. If you aren't familiar with AlgoKit's Algorand client, I recommend you watch the intro video that is part of this bootcamp series to better understand how the Algorand client works. But the summary is that this is the main way that we interact with the chain, the main way we create accounts. Basically anything to do with Algorand, we typically do through the Algorand client. And then we also get our test account from our context. And the context is updated each time we call before each. So basically what's happening here is we instantiate an Algorand client, and then we create a test account based on that Algorand client, and we get it from our context. And now what we can do is we instantiate our client by saying app client is new digital marketplace, and I'm going to send it from our test account resolve by ID. That basically means the client needs to know how to find the app on the network. In our case, this is a brand new app, so we're saying it's going to be an ID, and the ID is 0. On Algorand, every time we deploy an app, it gets a unique ID, much like assets. And so an ID of 0 means this app doesn't yet exist. And then in order to actually deploy, our client needs to know how to connect to the network, so we pass it our algorand.client.algod. And then finally, we can actually deploy our app by calling create here. So what I'm going to do is I am going to, before we can actually get to our create application, so let me come back here, what we need. For create application, we need an asset ID and a unitary price. Okay, so before we can actually start testing, we need to create an asset. So the easiest way to do that is do const asset create, and we're going to do algorand.send.asset create, and we're going to pass in the sender as test account, and the total, let's just mint 10, why not? And this should be fixed by the time you get to this video, but if you see this error, big int literals are not available when targeting lower than ES 2020, all you need to do is come to your TS config, find the target line, do ES 2020. I'll be sure to update the template so you don't have to do that, but just in case you see that again, that's how you fix it. And then we need to set the address here. Okay, so we're going to be creating an asset, and then I'm going to save that asset ID. So const test asset ID. That is going to be a big int, which we're going to get from asset create confirmation asset index. And I forgot my weight up here. I like this syntax a little bit better. And we know it's going to be an asset create. Okay. And so now up here, we can say that our asset ID is going to be our test asset ID, and our, let's see the argument, unitary price is just going to be 0. Okay, so just this code right here, what this will do is it'll deploy our app. But of course, we want to start writing some tests. So the first thing I know that I'm going to be testing multiple different functions, and they're going to be different callers. So right now I've used this test account object, but what I want to do is I want to have a single account that I can use throughout multiple tests, right? So I want to test this scenario where I have one seller, and that seller can then later interact with the contract. So what I'm going to do is I'm going to define a new variable up here called seller, and this is just going to be a string. And I'm going to say seller equals test account dot address. And then I'm also just going to update it here, just so it's a little bit more explicit. And so now what we have is we now have a seller account that we can use in our test down below. And I also know that I am going to want to use this asset in more of my test down below. So what I'm going to do is I'm also going to define let test asset ID. This is going to be a big int. And we're just going to get rid of this const here. Okay. So now in my before all, what I'm basically doing, and the general pattern you want to do, is do all the things you need to set up your tests and deploy your application. And then in your test, you can test the individual functions. So we've gone ahead and we have created our application now. And what we need to do is we need to start testing our methods. So if we come back here, first method I'm going to test is this optIntoAsset function. So I am going to, let me get rid of difference, and I'll get rid of all this code, and then I'll name this optIntoAsset. Okay. And so in my test, we're going to set it up similar to our before each, where we do a const algorand equals fixture. And then we are also going to get our app address from our contract. So in the optIntoAsset, I need to send some algo to my contract. So in order to get the address for the contract, I'm going to do await app client dot add client dot get app reference, and getting the app address from there. Okay. And so now what I want to do is I'm going to create a transaction to pay for the MBR. So I'm going to call this MBR transaction, and I'm going to await algorand transactions dot payment. Again, if you aren't familiar with the terminology of MBR and payments, we covered this a little bit in the smart contract, but to see a little bit more in depth about how this works, check out the intro video in this bootcamp series. But we know we're going to be opting into an asset in the contract, so we need that contract to have 0.2 algo. So I'm going to form a payment. The sender is going to be the seller. The receiver is going to be app address. The amount is going to be algo kit dot algos, and we're going to say 0.1 plus 0.1. So 0.1 algos for the account in order to be in the ledger, and 0.1 algos for the asset in order for it to be in the asset, or in order for it to be able to opt in. And then if we, actually, let me keep it like that for now, and then we'll come back to it. So this isn't all the code we need, but then what we're going to do is we're going to get the result of calling our app. We'll do await app client dot optIntoAsset, and we're going to pass in our MBR transaction. Okay, and again, remember, optIntoAsset, we require an atomic payment. So in order to do that, we form a transaction using Algorand client, and then we simply pass it in as an argument. Under the hood, what this is doing, this is creating a group of 2 transactions. First, the MBR payment transaction, and then our call to optIntoAsset. But we can do it kind of in one line of code here by calling optIntoAsset and passing our transaction that has been sent. Remember, Algorand also has this send. This would actually send the transaction. This just returns the transaction that hasn't been sent yet. And we're going to pass that as our argument. And if I go ahead and try to test this, whoops, there's a typo, npm run test. If I go ahead and try to test this, we will see a failure. And if we scroll up, we'll see that we failed to submit our inner transaction. So when we call optIntoAsset, we're sending an asset transfer. But you'll notice that we don't define a fee here. And we're doing this because we don't want our contract account to send the fee. Every time we deploy an application, that application has a unique address. And that is the address that is originally expected to pay the fee. However, since we aren't setting a fee, the fee is going to be 0, and we need to pay for that fee in our call to the transaction. So to do that, I'm going to modify my MBR transaction. I'm going to specify extra fee, and I'm going to give it algokit.algos 0.001. So giving it 1 transaction fee worth of extra fees. And if I go ahead and run it again, we should now see our test passed because on Algorand, fees are pooled. Every transaction by default requires 0.001 algo, including this inner transaction here in our contract. If I tried to send this, if I tried to call this, as you saw, without specifying that extra fee, AlgoD will look at the transaction group and say, hey, you're sending 3 transactions, but you only gave me 0.002 algo. I need another one. And that other 0.001 algo is used to cover the cost of this inner transaction. And that's why we specify here our extra fee. Now, we verified that we actually call it, but what we want to do is we make sure that this actually worked. So we're just going to make sure that indeed our results.confirmation to be defined. So we're making sure that our transaction was indeed confirmed. And then we're going to get our balance from await Algorand account.get asset information. And we're going to be passing it the app address, and then our test asset ID. Okay. And then finally, we're going to expect balance to be 0. Okay, if we go ahead and run this again, and we can see that it worked. And this is important to do because we're guaranteeing that our contract opted into the asset. If we were trying to get the balance of an account that wasn't opted in, so let me just do this real quick, algorand.account.random address. So if we try to get the balance of a account that wasn't opted in, this test would fail, as we can see here. So here with this expect, we are verifying that we have indeed opted in our contract to the asset, so we can now be ready to send it. But of course, we haven't yet actually sent it the asset. So we've tested the opt-in. Now let's go ahead and test our buy function. We're going to test buy async. And what we're going to do is, again, very similar setup. So actually, I'm just going to copy this here and paste it down below. And what we want to do now is we want to be able to send, actually, this should be deposit. We want to be able to make sure that we can send the app address some of the algo that we're opted in. So we're going to do result. It's going to be await algorand.send asset transfer. The sender is going to be test. Oh, that's not what I wanted. The sender is going to be seller address. Our asset ID is going to be the test asset ID. The receiver is going to be the app address, and the amount, let's just go ahead and say 3. Oh, this is already the address, so we just say seller. Okay, and again, we're going to expect results.com. Okay, just wanted to pause real quick to address, this question here. So this is an error that you might see in your IDE when you are working with the Algorand client and you are using a big int literal. So for example, if you take a look at the questions tab, you can see an example of this when we did algorand.send.asset create total 10n. You might see a squiggly line under the 10n. And in order to fix this, we just have to update our target version and our TypeScript config. I meant to update the template to do this automatically, but evidently I forgot to do that. So let me just share how we can do that real quick. So if you open up our project here, and here we have our digital marketplace with our test, our contracts folder. And if we come down to our tsconfig, in this tsconfig.json, which is under the project's digital marketplace, and we scroll down to where it says target, we're just going to change this to 2020. So make sure in your tsconfig.json, you have target yes 2020, and that will get rid of those warnings about using big int literals. So if you're seeing those squiggly lines, just change this to ES 2020. After this bootcamp, I'll go ahead and update the template so you don't have to do this every time. I just forgot to do that beforehand. So just make sure you got target ES 2020, and that should get rid of any errors you are encountering. Okay, let's go back to the contents. Results.confirmation to be defined. And then we're just going to copy this code here for checking the balance. Except, of course, this time we're going to be checking that it's actually 3n. So let's go ahead, run it, and make sure that we've successfully deposited to the contract. And we have. And now what we want to do is let's test our setPrice function. Okay. So we're going to do a test setPrice. Again, this is going to be async. And this time we just need Algorand from our picture. We don't need the app address. And what I'm going to do is I'm going to call await app client dot set price, and I'm going to set my unitary price to algokit dot algos. I'm going to set the price to 3.3 algos. Why not? And get the micro algos for that. So our unitary price, whenever we interact with the contract, is always going to be in micro algos. but we can use algokit.algos to easily convert from the human readable algo to our micro algo value. So we're going to go ahead and set our price. And so actually, let's just run this and make sure that that call is working. And then we'll talk about how we actually test that set price worked. While that's running, we'll come in and we can see 3 passed. Just as a reminder, all this function is doing is updating our global state value of unitary price. So what we want to do is we want to make sure that our global state value is 3.3 microalgos. So I'm going to do an expect, and I'm going to await app client.get global state. And I'm going to expect unitary price as big int to be big int algokit.algos 3.3 dot algos. Okay. And so actually I realize we don't even need algorand here. Okay, actually let me break this up into a couple lines of code just so it's a little bit easier to read here. So we're going to have our global state const unitary price equals global state dot unitary price, and we expect our unitary price to be big int algokit.algos microalgos. And you notice here, excuse me, you notice here that we're manually converting microalgos to big int. In the somewhat near future, AlgoKit will be updated to better support big int kind of across the board, so you won't have to do these manual conversions. But if your IDE is throwing you an error or your tests are failing because you're comparing a number to a big int, just make sure you do these conversions. But we do want to use a big int because this can be a UN64, which theoretically could be bigger than the largest number that's supported by JavaScript numbers. Okay, so we've tested our set price, and now we can come on down and we can test our next function, which is going to be buy. And so as you can imagine, we're going to have an async function. And we're going to do the very similar setup where we have our algorand from fixture. I keep doing that typo. Algorand from fixture, and then we're going to have our app address from await app client.get app reference. And then one extra thing we are also going to do is we're going to get a new test account. So far we have our seller address, but we need to have a buyer. So I'm going to use my context in my fixture. Every test we had a new test account. So I'm going to make a new test or get the new test account and call it buyer and get that from fixture.context. So now I have this buyer account that we can use. And I'm going to, well, first I need to opt the buyer into the asset. So I'm going to do await algorand.send asset opt-in. Sender is going to be the buyer, and the asset ID is going to be the test asset ID. And then after we opt in, we're going to want to form our buy transaction. So if we come to our buy asset, you see we need a payment that is sent to the contract to actually cover the cost of the asset. So I'm going to do const buyer transaction. This is going to be await algorand transactions.payment, again, much like what we did for the MBR. And this is going to be from the buyer address. Receiver is going to be app address. The amount will send 6.6 algos, so buying 2. And we're going to set our extra fee to algokit.algos 0.001. And the reason we're doing that is because we have another inner transaction. So we need to cover the fee for that inner transaction. So we have our payment to the app to actually buy the asset. And then we need to actually just make the call. So const result, this is going to be wait app client dot buy. And we're going to say our buyer transaction and our quantity is going to be 2. And now the other thing we have to do here is we're going to be passing a second argument where we define the sender, and this is going to be the buyer. So by default, our app client, because when we instantiated it, we take a look here. When we instantiate it, we say the sender is a test account, which is our seller. But now we want to use a different sender, so we're going to send it from the buyer. Okay. And then after we send it, we're going to, that was the wrong place. We're going to expect result.confirmation to be defined. Okay, so making sure our transaction is confirmed. And then we're going to get the balance of the contract again. Or we're actually going to get the balance of our buyer address, but we can use the same logic as we did up here. Except just change this to buyer.address. And we expect this to be 2n because our price was 3.3 and we paid 6.6 and we specified a quantity of 2. And so now if we go ahead and do a run test, we can now see that we have passed. So at this point, we've tested basically all the core functionality. Now, the one thing left to test here is our delete application. And so this is mostly going to be the same as what we've done. We're going to have test, delete application, and we're going to have async. And we're going to const algorand from our fixture. And so in our delete application, if we recall what we expect to happen, we expect the remaining algo and asset to be sent to the seller. So what I want to do is I want to get the balance of the seller before we call this. So I'm going to say, actually, hold on. To get the balance of an account, we do await algorand account.get information seller. And we can see here that we have an amount field. So I'm going to say my amount is going to be before call amount. Okay. And then basically we can now that we've recorded how much algo the seller has, we can call delete application. So await app, const result equals await app client. And now before we just did dot our method, so like dot by. And now we need to tell our client that we're going to be deleting. So we call dot delete and then dot our method. And then we don't have any arguments that we actually need to pass here. But what we do need to do is we need to cover the inner fees. So I'm going to modify my send params here. Oh, this is not right code. In the second argument, so the first argument is our method call args. Then our second argument, we have the send params object. Fee is going to be algokit.algos 0.003. Now, I should mention that this is actually not great code to do in practice. And you'll notice that the way we did extra fees here is different than how we did it in our Algorand client where we just defined extra fee. This will work in our test because we know our fee is going to be 0.003. But in real network conditions, fees can fluctuate. And so hard coding a fee like this is not recommended. However, it's the easiest way to do it right now in our test. So that's how we're going to do it for our test. And eventually we're going to be updating again in the near future. We're going to be updating the app client to allow us to specify an extra fee, much like we have before. But for now, we're just going to hard code it to 0.003. And again, the reason we're doing that is we have two inner transactions. So 0.001 for the outer and 0.002 for the two inners. Okay. And so now we're going to do, as you probably guess, expect. I keep waiting for Copilot, forgetting I have it disabled while I record, so it doesn't hallucinate on me. So we're going to do expect result confirmation to be defined. And now we're going to get our after call amount. Stop. This is going to be, actually, let me just copy this line here. After call amount. And what we're going to do is we're going to expect after call amount minus before call amount. So how much algo has changed to equal algokit.algos. We expect to gain 6.6 from the sales plus 0.2 from the minimum balance requirement minus 0.003 because we paid that in fees. So we expect to get back the amount that we made from our sale plus the amount that we spent to opt the contract in minus our fees. And then let me just, I guess, ESLint won't do that. Actually, I can get rid of this here. There we go. And then what we're also going to do is we're going to get the balance of our seller, wait algorand.account.get asset information, seller test asset ID. And we're going to expect that balance to be 8. And again, we already sold 2 and our initial mint was 10. So in our delete application, we're getting back all the unsold assets. So we expect there to be 8 left. And let's go ahead and see what's failing here. I just forgot to specify .microalgos. Okay, let's go ahead and run that again. And we can now see all our tests are passing. Okay, so at this point, we've written our contract and we've tested all of our methods to make sure they actually work. And in the process, we've learned not only about smart contract development, but how we can actually interact with that smart contract through our automatically generated client. Now, the next step, once we have our tests, is we're going to be going over to our front end. And before we get there, I do want to disclaim that this isn't full comprehensive testing. One important thing that we didn't do in this test that you should always do is do some negative testing. Like make sure that when you try to break the contract, it actually breaks and it doesn't allow you to do things you don't do. We could spend an entire bootcamp just on general SQA best practices, but this should give you a comprehensive enough idea that your contract works as you expect it to, so you begin integrating it into your front end, and eventually you can have, full stack end-to-end test as well. But what we're going to be doing is we're going to be jumping over to our front end, and we're going to be seeing how we can use a lot of the same principles we learned here. So using our auto-generated client, using that Algorand client to interact with the chain, and see how we can bring this kind of code into a production-like environment. I say production-like because this is not production-ready code. We're just doing a boot camp here, but it'll be similar to the process that you do when you actually go to production. And we'll be showing you how you can integrate into React. So in the next video, we'll be showing front-end integration. But at this point, we've concluded the segment on testing and smart contract development. And if that is all you're interested in, if you're not interested in front-end, I hope you enjoyed this series. If you are interested in front-end, then stay tuned. We'll be getting right into front-end development after this. Thanks, everyone. All right, so that concludes today's content. I know that it is a lot to learn in just an hour, so definitely after this session is over, you'll get a recording, and I recommend if you have any questions, you can come to our Discord and ask away there, and if not, we can address some questions at the start of tomorrow's session again. Tomorrow's session is going to be focused on front-end integration. If you attended the Python bootcamp, you've actually already seen the content. The front-end integration is the exact same for both Python contracts and TypeScript contracts because we use AlgoKit to automatically generate our clients for us. So if you attended the Python, the content will be the same, but definitely still attend these upcoming sessions so you can get the certificate at the end of Thursday's session. Let me see. I don't see any questions right now. And let me check the chat. Yeah, I don't think we got any questions. So, Camilo, you have any updates on your end?
Okay, Joe. So thank you for this incredible session too. As we discussed at the beginning, testing is a very important practice. And today we learn how to start doing that for our smart contract. And as soon as I receive the recording of today's session, I will try to replicate and understand the code of each of the tests. And each of them help us to understand the key features and concepts of Algorand that later we can use for our own project. And I'm really impressed of how AlgoKit makes our lives easier, because if you participate in our previous bootcamp, you need to do a lot of things by your own. But right now, AlgoKit helps us. And in the learning process, it's essential to replicate and then try to create our own solutions. So in these two sessions, we learn how to create our smart contract and doing the test to ensure that everything is working as we expect. And tomorrow we are going to create the user interface that is super important, and we need to keep working around that because that is one of the most important things to improve, because there are too many friction in the Web3 world that allow people that they don't know what's going on to start working with our solutions. So I don't know if we have more questions, or maybe there is something in the test that you would like to understand better, so maybe Joe can help us. But so far, I don't see more questions.
Yeah, just saw one come in about this extra fee here that we're doing when we delete the application. So whenever a smart contract call sends a transaction or an inner transaction, someone needs to pay for those fees. In this case, the person paying for those fees is going to be the person calling the delete application method. And so what we need to do, and this can happen because on Algorand, it doesn't matter which transaction has the fees paid. It only matters that the sum of all the fees in your transaction group equal enough to cover all the transactions. So in this case, it's easiest to just have the person calling delete application pay those extra fees. So we have one transaction for delete application call, one transaction for sending the asset, and one transaction for sending the algos. So that's a total of 3 transactions. And in order to cover the fee for those 3 transactions, we need to specify the fee as 0.003. Now, this is different from the extra fee field that we use in our other transactions because the app client is using a different interface than the Algorand client we use for our other transactions. In the future, our app client will have an extra fee field, just like all of our other transactions. But right now, we have to do it a little bit differently by specifying the send params and hard coding the fee to 0.003. So this method call calls two extra transactions. So we need to add 2 transaction worth of fees. So we take our default fee of 0.001 and then add 0.002 to make sure that all the fees are covered. And because all the fees are covered, we won't run into any errors. If we try to reduce this fee to like 0.002 or 0.001, you'll see an error saying that the fee was too small and it wasn't able to cover the inner transactions. And then a follow-up question, how can we discover that there's 3 transactions without knowing the internals of the method? Is that breaking the rules of a good interface? And yes, 100%. Unfortunately, right now, there isn't a great way to like statically determine that. Right now, the best way to figure that out, if you don't have access to the code, is to use a feature on Algorand called Simulate. And using the Simulate feature, you can test a transaction to see if it'll work before actually sending it to the network. And so what you can do is you can start with 0.001, simulate, and see if that's enough to send the transaction or not. And then you can increase your fees accordingly. In the future, it is currently on my backlog to improve this developer experience so we can have ways to determine how many inner transactions are actually sent. However, right now, if you are writing a contract and it could be a very dynamic number of inner transactions, it's generally helpful to have a method that tells the caller how many inner transactions there are. So before I call this contract, I call the tell me how many inner transactions method there, tell me how many inner transactions there are method, and that returns me the number that I use to write my fee. But fortunately, right now, there isn't a great way to do that automatically, but we are working on it.
There is one question from Jorge, if it is possible to get access to the download version for the sessions. We are going to upload the content to our channel, AlgoDev's channel in YouTube. But in tomorrow's session, I will share with you guys a link to a Google Drive. So meanwhile, you can have all the recordings over there.
Yeah, so we got a question about the opt-in method. And so on Algorand, whenever, and this is something we covered in the intro bootcamp. So I recommend either going back to the intro bootcamp if you registered, or in the very near future, we'll be posting it on our YouTube channel as well. We also have content on YouTube about assets, and particularly this feature called the minimum balance requirement. And basically, in order for any account on the network, whether it's a contract or just a regular end user account, the account has to opt into the asset before it can receive it. And so the opt-in method in our contract is a way to tell the contract to opt into the asset. So before we send it the asset, we need that contract to opt in. And that's exactly what we're doing with our opt-in to asset method. And what we're doing when we're testing it is we're seeing that before we call opt-in to asset, the contract is not opted in. And after we call that method, it is opted in and able to receive the asset. So we need a way for the contract to tell the network that it wants to be able to receive that asset. And then we do that through our opt-in to contract asset method. And then we can test that by making sure after we call that method, it is indeed opted in and it can then receive that asset.
And that is a pretty interesting feature that Algorand offers as a network, because in that way you can ensure that just will receive the tokens that you opt in for. So it's to approve the tokens that you won't receive. And in the smart contract is interesting to realize the way that it works also.
Awesome. All right. I think that is all the questions we had for today.
Yeah, so thanks everyone for joining us in today's session, and looking forward to seeing you in tomorrow's one, because we are going to add the user interface. So I'm pretty excited for tomorrow's session. Thank you, Joe, and see you tomorrow, guys.
All right, bye everyone.